Good evening, everybody. Hello, hello, hello. May I have your attention, pretty please? Excellent. Thank you, Ron. I appreciate the thumbs up and the encouragement and support. I love that. Back at you. I have a quick little brief non-meeting announcement from Mr. Jim back here. He has something interesting which everybody's going to be interested in, and
Well, thank you.
I will,
At Suresh's suggestion, I picked up an extra equatorial platform for my Dob, and I've been trying to sell it on the forum, and it's gotten a lot of views, but not necessarily a lot of people looking at it. So I brought the platform that I have along, and I have it set up back there. I'd love to show it to some people. Maybe you can help me generate some interest. I'd like to sell it. Ukrainian made. They're really hard to find now because of the war. So I have the pro version of that I use on my Dob, but I've got one that would work for most 10-inch and smaller Dobs, and it just does a beautiful job of tracking. You just flip the switch on and stays right there in the eyepiece, and it gives you a chance to chart things and change eyepieces. So
okay.
thank
And
you
how can they find you? Who are you?
I've got all my information back there.
I know, but for the people online that can't.
Oh, online. Okay. Jim Peasley, and the email address is Jim Peasley, and then the letters LMFT, as in licensed marriage and family therapist, at AOL.com. So Jim Peasley, LMFT at AOL.com.
Perfect.
Thank you.
Yep, not a problem. Thank you, Jim. And don't everybody go rushing back there quite yet. Well, I guess you could just be very quiet about it. All right, so we're going to welcome you here to the March 2024 MAS General Meeting, and we are not talking about the budget. Anybody that says that can leave the room. We have, and to support that, we have the California Nebula, which looks like flames to me, by Mr. Chris Setness. So thank you, Chris, for providing that photo, which we finally get to see tonight instead of which one we didn't. And let me see if I can get my little clicker awake. Oh no. All right, well, it is, but none of it wants to work. Oh, no, this way. Maybe I'm going the wrong way. All right, MAS board. What? It was free. It was great. This is a great thing. I just don't know my forwards and backwards. I know. I should put B and F. This is your 2024 board, at least half of it. Here is the other half. And if you see us around, say hi. Don't ask us budget questions yet. We're not up for that. This is a photo from Nick Hartman, but I have no idea what it is. He never responded to me as to the fish head. Oh, part of the heart, fish head. Okay, now I see it. That's pretty cool. Kind of interesting, but then again, it's like, it doesn't look like that in real life, and that's what I want to see. But in a moment here, I will give this over to Matt because it's his turn. This is from Alan. Yep. Do you want to talk about CGO imaging rig?
This was the Takahashi at CGO, and this was a live stack. And I just did some post-processing adjustments in Affinity Photo. So this was a while ago. Interesting star spikes are unexplained.
Okay.
And they're only on the left side there on those two stars. So I don't know if there's a spider web or something in front of the pixels or what, but something weird that's just unexplained. Yeah. Anyway.
It's okay.
But it's a neat image. I like it.
I mean, image, yeah. Okay. Well, I guess we're using touch fingers tonight instead of clickers. I would like to welcome the new members that we have. We have, yay! I don't know if anybody's here in the room that's a new member. I think there's, yes, excellent. Welcome. We love seeing you here and thank you for showing up tonight. Are there any guests here tonight that are not members? Welcome, welcome. So we got two. That's wonderful. And we're going to quiz you later on how you found us and what, so we can get some feedback. So that's lovely. So thank you. And if your name's up here and you're online, just type in the chat, hello and welcome. And you're still up, even if it was last month, it's fine. But this is everybody. This is amazing. So thank you so much for joining our little club and just being here tonight as a guest and learning about more of what our club does and our astronomy. And hopefully you share our passion for all of that. Right. And these are the few things before our next meeting. We're unfortunately getting more daylight than nighttime, as it always happens. But we also have a few conjunctions and the vernal equinox, which should be interesting. And I'm not quite sure what the penlunar eclipse is. Penumbral. Okay, thank you. I just thought it was really interesting the way that they put it, and it's like, okay, I know somebody here will know what that is. So, and then we are back here on April 4th, which leads me to the next question. If I could have a show of hands from the people that are in the room who are going to want to be in person in this room next month. Because on April 4th, because a lot of us are traveling, and I'm assuming that because nobody, raised their hands, everybody is traveling, which includes me. So I will be on Zoom doing the presentation, which we are still having one. It's just whether we, have it completely on Zoom or whether we have somebody here in person in the meeting room to do all of this stuff. Yeah.
If you need somebody here, I can be here because I'm
Okay.
not traveling for the eclipse.
Okay.
So if you need somebody here in case people come to visit,
Okay.
to be part of the meeting, I can be here.
Well, that's kind of just why I was asking. It was like, okay, do we do it?
I can
Do we
also
not
be
do
on
it?
Zoom from home.
Yes, you can. Yes, you can. Does anybody have any feelings either way? No,
Yeah,
no.
Trina, I don't think it's gonna work from here because we need the AV equipment, and if Matt or John are not gonna be here in the room, we're not gonna be able to run the meeting online unless whoever shows up with their own laptop.
Okay, all right. So with that being said, the few people that have the AV stuff and we'll just keep it simple. Next month, April 4th is going to be Zoom only. That way everybody stays home or traveling can tune in or not as they're, going around. And then we'll just meet back here in person in May.
Doing it COVID style.
Yes, but on a fun way. No COVID requirements, but yes. Of course, of course.
We'll update the website.
Yeah, so spread the word, have other people, talk to everybody saying, please don't come to the meeting room. And then we'll just also let the front desk downstairs know that there's just not going to be anybody here and to kind of skip it. So thank you very much for your feedback. Oh. Yeah, I did get ahead of myself. Usually John is here. I don't know, is Anton online? I don't know if he was going to be or not. Okay. Dave, do you want to come up and talk about the Lunar Scope program for me instead of everybody listening to me yammer? And tell our new guests and our new people what all of this is about.
Hello, everybody. My name is Dave Faulkner, and I'm the secretary, but I do know about the Lunar Scope program. This is a program that we have for members to be able to check out a telescope for a month and then you return it. Anton runs this program. We have, I want to say 12 telescopes.
18.
Oh, 19. 18 or 19 now. And they range. I mean, we got Dobbs, we got refractors, we got Schmidt Cassegrains, we got a solar scope, we got binoculars. So, any telescope you want, you can check it out for a month. And it comes complete with, all the stuff you need, the eyepieces, the star charts, the red flashlight, everything you need to go out and do stargazing. So it's really cool. And it's a great chance for you to try out a telescope, particularly if you're still, trying to figure out what kind of telescope you want for your personal use. Eventually, it's a good way to try out a few different types and see which one you like. Okay. Then along with that, we also have these what they call courses in astronomy.
Yeah,
Okay.
master courses.
And you can see there's a whole bunch of them there, and I've heard they're very good. I personally haven't taken one out, but you
I
have. You
I've
have.
had done a couple.
Yeah.
Yep.
And I've heard
Yep.
they're very good. So,
Yes.
and that's just the same deal. So I think you take it out for a month or
A month
more.
or two.
Or
yeah.
two. Yeah. I
there's
think
usually
he
not a
allows
huge
2 months
request.
on these because it takes a while to get through the course.
Mhm.
And as you can see, it's all kinds of topics about astronomy. So it's a great asset, a great perk for for club members. And you should in order to do that, you have to go on to the website, and you fill out a form on the website, and that is automatically emailed to Anton, and he will contact you, and you can make arrangements to either pick up your scope or your course. Okay, is that it?
Yep, that's it.
Okay, great.
Okay. And
Thank you very
then-
much.
Why is my slide the wrong way? Hold on. Nobody look at the next one.
What?
Oh, man. All right, hang on. Because how do I do this? I need to unhide a slide for you guys. I don't know why, but it's hiding. I did, and I don't know why. Yeah. Okay, there we go. Okay, so it's now unhidden. So the upcoming star parties, we have the first of the ELO public star parties that is happening on March 16th, and then the second one on March 30th, and they're starting at 7 o'clock and go until 10 o'clock or whenever people go home. So everybody is welcome to come out and take a look through 4 to 6 telescopes and have a good time and have a speaker or something sometimes going on. So keep an eye on the forum for any changes, and it still goes if it's cloudy or rainy, but not as much fun, but it's there. And then the BSIG presentation is on, I forgot the date, March 23rd. Thank you. And it's featuring Ahmed Part 2 on the golden age of medieval Islamic astronomy. So that will be interesting. And then we have our first star party of the Cedar Creek. Nope. Yep. All right. Do you want to say it? Okay.
So as this is part 2 of what Ahmed's going to present, people that want to catch up can see part 1. It's on the MAS YouTube channel. It's out there. So be
Mhm.
sure you see that.
Yep. Excellent. And then, of course, Cedar Creek, that's kind of our little thing. And come out March 16th. We just kind of hold it. It's up at East Bethel. So and then JJC is open because you can get to it. CGO is open because you can get to it. And LLC is open, which I think their first weekend is starting this weekend. And you have to kind of register on the forums to make sure that you have a room to sleep in. And we're adding a little something new because we have have these ahead of time. So these are the key holder trainings that are going to be held. You have to register in the forum. Doug, do you want to talk a little bit about it? Okay. No, I want Doug and Dean and Doug and Peoples to talk about it because that's theirs. Yeah.
This is Doug Deverman. Yes, the ELO, we have 2 sessions in April and May. There will be registration that you can do online. I'll send something out into the happenings and put something up on the forum. But you'll be able to take, there's one training that is required, one module that's required, but then there are other modules that you can take after that. So it's something new we're trying this year. And we've been busily changing the packet, the training packet materials to match that. So come on out. It's a great time.
Yeah, of course it is. Now, are these,
There's a question here. The signing up part, Dean wants me to mention that the signing up part will be different. What we done in years past was you would sign up on the forums. But this year, we're doing something different. There will be a web page that you go to that you will register, select what modules you want to take. And when you submit that, then it sends an email basically to me. So I know who's coming and I'll respond to it saying, okay, all right, you're signed up. And so that's how that's going to be done. It's actually kind of available right now from the website, but I'm going to make some changes to it. So I'll send out something in the forums and in the happenings that say registration is now open.
okay, perfect.
And the happenings, what I'm planning on doing there is having a section at the bottom of the happenings with all of the upcoming trainings. And when you get that page, I'll put the link in there to go and register and all that. So every happenings will have that. And then as the trainings occur, I'll take those dates off. But they'll have all, the future dates of training that we have so that people can plan ahead.
Excellent.
Oh, you're welcome.
Yeah,
If you look at the last happenings that came out this week, you'll see all of the ELO trainings sessions. So
yeah.
we have some in July and August, I think, and then one in September. So we're having 3 training sessions
Yeah,
this year.
I just didn't put them in because then it would make everything so tiny, nobody would be able to read it.
Okay, that's fine. I'm just saying.
Yep, there's still more out there. Yes. How do you get on the forums? You go to mnastro.org. And then over on the very top bar on the right-hand side, there is a spot that says forum. And you need to, no, I think it's, no,
No, it's
it's a
on the
forum.
forum.
It's an actual top level link.
It is.
Yep, it's a top level link. And then you create a username with password and you can get into, once you're approved from Peoples.
I think the top right forum.
Yeah, top right of the forums. What did? Oh, I usually just go onto the top and that gives me directly to the forums.
Yeah, maybe.
Anywho, we will get you there and then you create your login and then you can get into there and it's a whole list of directories. And if we can always touch base a little bit later to walk you through it too.
Trina, I just need a minute here.
Okay.
Okay, so thank you, Doug, for organizing the ELO one. As you can see here, effectively all sites are going to have key holder trainings and they're going to have different ways of registration. Doug just talked through the ELO one. For the other sites, reach out to the site coordinator to get into the training for JJC, CGO, and LCC. And pretty much every site is going to have about 3 to 4 trainings this year for members to become key holders. The key requirement is you need to be you need to be a member to train as a key holder. So that, yes, anybody can register for the forum, even if you're not a member, but in order to actually register for training and be able to attend the training, you got to be a member of the club.
Okay. And if you have any further questions about that, just give us a shout and we'll be able to help you and walk you through it. All right. Okie dokie. Thank you. I believe I have the correct number of days to the eclipse. You have 31 days. If you haven't done anything and are going to go see it, yeah, going. Yes, but if you're going to stay here.
For those who traveled for 2017, a little word to the wise, don't try to go out there the morning of.
Very
You'll
true.
be sitting in traffic.
Yeah, very true. There's a question over there. Hold on.
This is the very first total eclipse I'll ever see, and obviously the very last one I'll also see. So I would like to ask the group if I could talk with someone afterwards to for tips to make sure I do it right. So after the meeting, I'd love to hear. All right, fine, thank you.
Oh, yeah.
We meet at Pizza Luce just up
Afterwards.
Snelling afterward, and there'd be people
That's-
here that could
yeah.
talk to you too.
Yeah, but otherwise, if, if you guys have some time afterwards, come talk to him. Yes, Ron? Right. Yep, exactly.
So you want to repeat that somehow?
I will. Hold on, I put it back up. Just bear with me. Tomorrow night's a Bell Star Party. Ahmed's B-Sig thing. Sorry, Ahmed. And then we have a little notice, which I think went out in the happenings as well, which is the theater in the round. This seems really interesting to me because I know Dave Faulkner has talked about that before. And about the Henrietta Leavitt, which is what the Silent Sky program is about. And she's one of the computers from the Harvard College Observatory in the early 1900s. So, and then I believe badges are in the back of the room. If you're here, please grab yours, take it home. We want to lighten Chris's load. And if you need a new one or want to change yours, see Chris, and there's forms back there as well. So, and then is there any other public service announcement anybody has? Okay, no, good. If not, let me know for next time. I'll just quickly go through this because I know I want to get to the next presentation. How long is yours? Okay.
4
hours. Okay, so through our club, every member is part of the Astronomical League, which is our parent company, parent organization, and which you're going to be voted next president for next time, so you can come up here and I could pick on you. They're a wonderful way to do observing lists and get cool things, but they also provide you with a reflector. I feel like twice every other month or every quarter. Thank you. And then you have really cool pins if you do the observing list, as you can see on the right-hand side. Just a few of them out of the 80 plus that you are able to do. And then certificates you get and pins. And if you want to see the bling, a few people around here are having bling, which I forgot to put my bling on, but people at home, that's what they look like. There you go. And I don't have any awards this year or this month. So hopefully next month I will. Next month it could be you. And then as Jerry says, get out there and observe. Yes. So to follow up, the MAS is on YouTube. So previous slides, part one of Ahmed's presentation are all on YouTube. Just go out there and look us up, and they have the beginner special interest groups. They have the imaging playlist, new member orientation. If you want to check out, it's just anybody can view it. You don't have to be a member to look at it. So.
And just one thing about the YouTube, if you haven't been to that channel, our channel before, and you just go onto that channel, just look up Minnesota Astronomical, it comes right up. And the introductory video is a nice introduction to the organization.
Yep. Thank you, Matt. You do not have to like and subscribe, but yes, you may.
Yeah, we're
No.
not monetizing, okay?
No. Okay. And then last call for Gemini articles. They are due March 10th. So please submit them to Father Brown. Otherwise, the next one will be on May 10th. And of course, published in April and then published in June. Dave already, yes? You want to talk about this or the previous one? Okay.
Just Father Brown prides himself in making sure that all the articles in the Gemini are written by members. And I know that he's going to be looking for articles about your eclipse trip. So take notes and, write a little blurb when you get back, and have a few pictures because he'll love that. So, because I think this whole room is going probably someplace in the United States. So it'd be fun to hear about your excursions.
The good, the bad, and the ugly, and the funny. So all of it, please. And as far as, yeah, I think we are the only newsletter that only does our membership. People have wanted to put ads and such in it, and we've said no, because we don't need to. There you
We're
go.
that good.
We're that good. Yep, we're that good. We have a lot of stories and we certainly talk a lot, so why not write them down and submit them? And of course, you'll see the secretary, email little blurbs to secretary at Astro, and Dave will get it in the happenings. Anything and everything that's astronomy related will go in. And then I know we saw this last month, but that's okay. I found it really cool. So right now at this moment, I'm going to hand the non-working clicker over to Claire, and she's going to give us a presentation, which was supposed to be like the Better Noah constellation.
Don't announce it. Yeah.
But we need to find a new name for this section. So if anybody has any ideas, please email them to president@mnastro.org, or just come up and tell me that we need something new, because it's not just about us, it's just about the members and sharing what they're passionate about or something new. So there you go. And then
Okay,
just,
if I don't want to use the clicker, I can. just
yeah,
use
the
that.
clicker's not working. It should,
Okay.
if it doesn't work, then just touch the screen.
Oh, can I just use this?
You should be able to.
Okay, can everyone hear me? Okay, ready? Okay, we got a new name, I think. So yeah, I think this is my third time volunteering for this gig of Better Know Constellation that might change its name. The first time I did the most adorable constellation, which is Delphinus the dolphin. And then I chose the most invisible to the naked eye constellation, which was Camelopardalis. And so in the spirit of Alan, who likes to shake things up and do something totally different tonight, I decided that instead of choosing a constellation, we would talk about that you, by the end of this presentation, had better know an obscure catalog. Okay. And not just any catalog, but tonight we'll be talking about star cluster catalogs, and specifically open cluster catalogs. So why on earth did I pick this topic? Well, we talked about the Astronomical League programs and all the bling. And so those of you who are visual observers who like to collect the bling, I'm right there with you. I enjoy it also. My favorite one so far has been the Globular Cluster Observing Project. That was hands down my favorite. I really enjoyed it. One thing that I liked about it was that in addition to logging the objects after observing and logging the objects, you also have to classify them. So there's the Harlow-Shapley classification system, and you have to get more experienced at doing that. So when I finished that project, I thought, well, I enjoyed the classifying so much that why don't I do a similar project, do the open clusters, observe those, try to classify them. It's a different classification system. And I sort of naively in my mind thought that, well, globulars would be the hard ones and the open clusters would be easy because that's like the Pleiades, right, Alan? Or the double cluster in Perseus, that kind of thing. But what I discovered is that project is, while there are some of those gems of the night sky in that project, it's also filled with some really challenging, obscure open clusters that come from these very strangely named catalogs that I had never in my life heard of before. And some of you who've been with me down at Cherry Grove, you know that I've been cursing and swearing this project for a while now, naming these catalogs kind of under my breath in a not so great way. So I decided this spring to change my attitude a little bit about this project. I'm about 40 to 50 objects into it. I think it's 120 total, and I got to stick it out. So what can I do to motivate myself? I could actually go online and learn something about these catalogs, like who are they named after, where did they come from, and how did they end up in my observing project? So that's kind of our point here tonight. And just quickly before we start, a quick refresher. I know most of you probably know this already, but if we're talking about globulars, Those are some of the oldest stars in our universe. Those are the densely packed balls of stars that exist in the halo of our galaxy. Open clusters, on the other hand, we're talking about some of the youngest stars born in the stellar nurseries in our Milky Way. They're kind of clumped together as siblings and have moved off on their own, but will eventually disperse. But we have the benefit of being able to observe them as they are right now. And another thing to appreciate about some of these obscure catalogs is that the project over the past 100 or so years to survey the sky, catalog all these objects, analyze all these clusters of stars has given us a lot of knowledge about the life and death of stars and also the Milky Way, the size, the shape of it, our location, that kind of thing. Okay, but I have a fun surprise in addition. So if somebody could help me pass out a few handouts. I'm going to invite your participation. I didn't know how many copies to make. And also I know we have people, sorry. I know, yep, okay. I know there's people online who don't have the benefit of getting a handout. So I have a way to facilitate this with you online. So if you do have a piece of paper and a pen or a pencil, I would encourage you to grab that right now. And here's the surprise. So I've got these obscure catalogs listed on one side of your handout, and on the other side is a clue. And as we're going along tonight, what I would ask you to do is match the clue with the catalog that you think I'm talking about. Some of you may know a few of them, but it's a guarantee that some of these you've probably never heard of before in your life. And for those people who guess correctly, I have prizes, and not just any prizes. I have cookies, and not just any cookies. These are fortune cookies that have actual astronomy fortunes inside. This was not my idea. You can blame Setness for this. This was Chris's idea. Astronomy fortune cookies, and these are guaranteed to be more accurate than your weather app for your money back. I am the astrologer to the astronomers, so guilty as charged. Always read your astro fortune before you go out observing. That is my advice. No, you can do it as we go. You don't have to match them right now. We'll work through it. So just a few things before we go. I'm going to give these clues. I'm going to go through the catalogs in alphabetical, chronological order from the oldest in my observing project to the most recent. Some of these weird catalogs are really mixed. There are some objects in the catalog, there are genuinely unique open clusters that don't exist in any other catalog, but there's a lot of crossover with some of these as well with NGC and IC and other catalogs. As opposed to globulars, open clusters are in the Milky Way, so you'll find most of these along the Milky Way, which is one of the reasons they're so challenging, because let's say they're in Cygnus, for example, right? It's in like in a part of the sky where everything looks like an open cluster. And how the heck are you supposed to know? I know. So like, how on earth did people figure out that these were actual clusters of stars? I have no idea. And some of these were discovered visually through big telescopes, but some of these were discovered by guys who were combing over photographic plates. And so they had that advantage that us amateur visual observers don't have looking through our telescopes. And you'll hear a few famous names, maybe like 2 or 3 names that you've probably heard of before, but a lot of names that you've probably never heard of. Okay, I think that's it. Are we ready? Okay, obscure catalog number 1. This was compiled in the year 1915. It's a large catalog, 245 stars. It does include some globulars in there. The majority of these are not unique. This one is named after a British astronomer. And we talked earlier about human computers. I think it was Henrietta Leavitt. Okay, well, this guy was recruited as a young boy to be a human computer at this observatory. And that was one of the ways that the Royal Greenwich Observatory recruited people to permanent positions, was through this pool of young people who could do temporary computing. And he became quite an expert at these photographic plates analysis and even converting some of these to paper reproductions. Photography at that time, they were just discovering how important that was to be able to discover things. So in addition to open clusters, he also discovered one of the satellites of Jupiter, Jupiter 8. He did also participate in the eclipse trip of 1922. Not the famous one in 1919 with Eddington, but the one after that. And the weather was bad, so we didn't get to see anything. Who was this British astronomer? And so people online, here's the list. So who do you think we're talking about? You can write it down. And you don't have to shout it out now. We can go over things at the end. Also, no Googling, no phones and no Googling. Okay, obscure catalog number 2. This one was compiled in 1930. This is our dude when we're talking about open clusters. This is the guy. This might be somebody that you've heard of. His catalog's got 37 open clusters in it. The majority of these are actually unique to this catalog. He's a Swiss-American astronomer who emigrated to the US during World War I, dropped the umlaut in his name. And he ended up working as the assistant astronomer at the Lick Observatory in California. He also attended the 1922 eclipse trip and collected data. That was Einstein's theory of general relativity, the bending of light around large objects. He also collected photographic plates and actually bettered Eddington with his data. He used photography to analyze the channels on Mars and figured out that, came to the verdict that they were natural, not Martians. And you could do a whole presentation on this person. He's well known for studying star clusters, studying the motions of stars, and creating the classification system that torments amateur astronomers to this day. Who are we talking about? Which catalog? Oh, and quickly, let me. You have heard me make so many jokes about this one. I'll say the joke later after we're done. And just quickly before we move on, I don't want to spend too much time on the classification of open clusters, but this is what he came up with. So it's the degree of concentration of the stars, the range of brightness that you see within the cluster, and how star-rich or star-poor the clusters are. And then occasionally, like the Pleiades that we saw earlier, you'll have nebulosity in some of these because they're carrying the nebulosity of the stellar nursery in which they were born. I put this quote, I found this from somebody online who's talking about, after studying some of these objects carefully and trying to classify them, he doesn't. I've had this experience too, where what I'm seeing through my scope and what the actual classification is, I'm like, really? I don't know. But maybe if you were looking at a photograph, it would be different. Okay. So who's one of our main open cluster guys? All right, obscure catalog number 3. This one was assembled in 1930 by Harlow Shapley. He's one of the guys that you probably have heard of before because he's famous. He put together, this is not actually what he's famous for though. His catalog is 21 open clusters that are fair, sparse, not always listed in charts. And even among this list tonight, this is one of the more obscure catalogs. Okay, so he's better known for other things, like he's better known for estimating the size and shape of our Milky Way, and like I mentioned earlier, our sun's position in it, and things such as that. All right, which catalog is that one? This one's obviously not named after him. I just put hints on the slide before. I told you these would be hard. If you're finding these hard, welcome to our world. You should do this project. All right, obscure catalog number 4. You can always guess too. 1931, assembled by a Swedish guy. This is a very large catalog of 452 open clusters. Named after, he was not an astronomer, but he was a historian of astronomy in Sweden and also an expert in navigation around the waters of Sweden and the Arctic. But he did write a dissertation on open clusters and obviously assembled a catalog. Who is the Swedish guy in this list? All right, are we finding it difficult? Like painfully difficult? All right, everybody gets a cookie no matter what. Everybody deserves an Astro Fortune after this. Okay, obscure catalog number 5. This was assembled from 1938 to 1941. All right, this one you might know. It's only five clusters, 4 of which he actually discovered, one of which was a rediscovery of something that was already known. But this is the guy who discovered Pluto. So he was an American astronomer working at the Lowell Observatory and discovered Pluto. The only reason he discovered open clusters was he was looking for other trans-Neptune objects in addition to Pluto and came across these clusters. This one you might have a good chance of knowing. All right, the torment. I'll go quickly. All right, catalog number 6 from the early 1950s. I thought this one was cool. Dave Faulkner will really like this one. This is a catalog of 24 open clusters assembled by a German astronomer who made huge contributions to astronomy in Latin America. So these 2 observatories, the one in Chile and the one in Venezuela. In Chile, he was one of the guys who rode around on his horse up and down the mountains and scoped out the site for that observatory. And he was the first director, right? And then he moved to Venezuela in like 1971 and became the first director of CETA and was one of the founders of that observatory as well. So this was kind of a cool one. Again, even the Swede and the German don't have names that sound very Swedish or German, so it's kind of hard to, right? I will reveal all at the end. Obscure catalog number 7. This one is interesting too. 1958. These astronomers working at the Palomar Observatory using their sky survey put together a list of I talked about how open clusters are the youngest, some of the youngest stars, but they assembled a catalog of some of the oldest open clusters that we know of, the oldest and most distant ones, including, I think it's number 17 in this catalog that is the oldest known open cluster in our galaxy. Again, a hint, this one isn't named after the astronomers. And they were working at Palomar Observatory. Hint. All right, we're getting there. Obscure catalog number 8, 1958. All right, 176 open clusters. This gentleman was from, yes, he's a Czech astronomer. And the International Astronomical Union tasked him with assembling, at that time period, the definitive list of all the known star associations. The OB associations are like once the open cluster disperses and the stars move off to different parts of the Milky Way, they're still related, but they're no longer together. He put together that definitive list that was foundational to mapping of our Milky Way galaxy. Another hint, the Czech name doesn't really sound Czech to me. At the end of this, you guys are totally going to want to do this project, I know. Obscure catalog number 9. We're almost toward the end. 1966. This gentleman was an American who studied under some famous people, Harlow Shapley and Bart Bach, I think the guy who discovered the Bach globules. He was more known for studying globular clusters, but at some point in his career, obviously assembled a list of open clusters as well. He did contribute to the Hubble, one of the camera projects, and he passed away only recently at the age of 94 in 2021. So since COVID, actually. Who was that? The American astronomer known for globulars? Probably not. All right, these two go together. We're almost at the end. Obscure catalogs number 10 and 11, assembled in 1966. This is a really good one. I like this one because these are not even actual real open clusters. These are not, most of these are not true physical clusters. They just obviously appeared as star clusters from our vantage point in rich areas of the Milky Way that are very difficult to find, but named after 2 Georgian astronomers. The first astronomer put together the catalog of 57 objects, and then he was joined by another Georgian astronomer who helped him assemble the last 11 items in the catalog. Who are our 2 Georgian astronomers? Yeah, not Georgia in the US. Yep, the Abostamani Astrophysical Observatory, actually. Okay, our 2 Georgians. I mean, this is like one guy and then one guy and the other guy. All right, this is our last one. 1989, obscure catalog number 12. This is 13 mostly unique clusters. All right, and this is an observatory. I won't name the observatory in Armenia. That was one of the main astronomy centers in the former USSR. It's now a United Nations Astronomical Heritage Site. They've done lots of sky surveys, found lots of objects, and according to this observatory, there are 14,500 cosmic objects that have Armenian names. I didn't know that. All right, so who are the Armenians here in our list? There were the Georgians previously. Yeah. Don't give it away if you know. Okay, are you ready for answers? If everybody gets cookies, everybody earned a cookie for this one. All right, the first one, any idea, any guesses? Melot? Yep, okay. Philibert Jacques Melot, he was our young boy computer who later became good at photographic plates. Yeah, do you want to give out the cookies to people while we're doing that? And then open it and read your astro fortune inside. Oh, sorry, I gave it away. What was number 2? You've probably, yeah, okay. Do you want to say it, Chris? Trumpler, more like Dumpler. Trina's heard us say that many times. All right, he came up with the classification system. Harlow Shapley was working at Harvard, so his really obscure one is the Harvard catalog. You got the Harvard? All right. Got Trumpler. All right, after that, what was the next one? Oh, this was the Swede. Okay, Per Collender was our Swedish navigator / historian. Yeah, everybody gets a cookie. All right, who discovered Pluto? Clyde Tombaugh. Woohoo! And a bunch of really 4 really dumb open. I mean really interesting open clusters. All right, Dave. Jürgen Stock. Yeah, he was the guy working in South America. The oldest catalog of old open clusters, that was the Berkeley catalog. And our Czech astronomer who came up with the definitive list that helped us map the Milky Way, that was Jaroslav Ruprecht. All right. Ivan King was the American astronomer who was an expert on globulars. Did anyone know that one? You knew it? Nice. You get a whole handful of cookies over there. Oh, you did. Okay, cool. All right, so our two Georgians were obviously Dolidze, Madonna Dolidze, and then GN. If anybody can say that name, you get the rest of the cookies in the bag. Jim Selevsvili. All right, and the final one, the Armenian Observatory. There's two different spellings for it, but it's Beerkon is the catalog, the Beerkon catalog. Yeah. Totally. Nice job. Okay, I thank you. I appreciate your patience. But now you know if you ever do this project and you see these very strange names in your lists of star clusters, this is where these names come from. Oh. Do you have them? Okay. Okay. Dave Faulkner's fortune.
My fortune is take time to observe that bright object on your horizon.
There you go. Chris got the same thing. Rebecca.
To see what you're looking at, try focusing.
I don't know. Hold on. Let's see. Your lucky NGC numbers.
I have a question. Claire, you said something that kind of surprised me. One of these catalogs had star clusters that were just assortment of stars, not necessarily related. So do they classify a difference between stars that are chemically related out of the same original nebula and then just, hey, here are a bunch of stars that are in close proximity?
I kid you not that a couple of these, including I think that was the Georgian one, right? I have to look back at my notes. A couple of these, it was very difficult to even find information. Like that guy, Per Collender, there was nothing known about him. And then there was some woman in Amateur Astronomy magazine, if anybody's ever heard of that magazine, who like rediscovered him and wrote an article on him. But I could not find any information on why there could be open cluster objects that were not true open clusters, but were still in the project or still considered legit catalogs. I don't know the reason. Do you know the reason, Dave? Okay.
But the question I have for you is one of yours had open clusters like 450 open clusters, but 470 objects. What do you mean by that?
Like some of them had globulars or other objects that weren't open clusters. In the catalog. Yeah. That was the Collender one, right? Or there was, yeah.
Oh, there's a question over here. Okay. Well, we're almost done with it.
Yeah, so this isn't a question, but I just felt it was really important to share my astronomical fortune.
Yes.
Which says, when in doubt, avert your vision.
Averted vision is the astronomer's friend.
Also helps if you're in Las Vegas.
All right. Shall we? Thank you, Claire. That was wonderful. Always entertaining. I appreciate that. See, and she's done it several times and has not melted into the floor. So everyone can do it, and we'll come up with a new name for the presentation. So, and right now I would like to hand over and stop sharing my screen and have Mr. Chuck Allen share his, and we will hear from the Vice President of the Astronomical League. Oh, if I can get my screen to work right. About, oh, there you go.
Thanks a lot. I really love not going first because it gives me an opportunity to hear what you guys are doing. And I get put first a lot, so I don't hear a lot of what's going on with the clubs. And your club is one of the premier clubs in this country. And we very much appreciate your membership and your participation in the observing programs and so forth. I wanted to come in person to this meeting, but I got caught between judging 3 science fairs, a physical exam, and eclipse presentations, and I just couldn't do it. But I really hope next year that you'll have me back and I'll make the trip, which I plan to do this time.
Definitely.
And so what I want to talk about tonight will be, I think, of interest to seasoned observers as well as beginners. So let me go ahead and share screen, if I may.
Mm-hmm.
And we'll go to, there we go. Can everyone see that okay?
Yes.
Okay, and the audio still good?
Yes. Audio.
Okay, great. I'll try to keep it that way. Andromeda, of course, is one of the most popular targets for all amateur astronomers as well as professionals. It's the closest major galaxy to us, not the closest, but the closest major. It's rich in H2 star-forming regions, has many companions, as we'll discuss, many globular clusters. And for those starting out, it's quite easy to find. You just need to learn how to locate the great square of Pegasus and work your way up through 2 pairs of stars in Andromeda to point right to a patch that's very visible to the unaided eye in a reasonably dark sky. And of all the objects in the sky, probably none has the historical heritage that this object has. No galaxy has ever created greater mystery for longer or unlocked more secrets regarding the size and dynamic nature of the universe than this little oval patch in the constellation of Andromeda. At the risk of perhaps boring you for just a minute, I need to explain how that mystery unfolded. And it started over 1,000 years ago. And it started with this gentleman, Abd al-Rahman al-Sufi, a Persian astronomer, who wrote a book called Book of Fixed Stars in 964. And this is the book that contained the first known record of an observation of the Andromeda galaxy, Messier object number 31. He described it in his book as a small cloud, and the reason he included it is because the small cloud never moved. It was always in the same place year after year. But more time passed, and 4 years after the invention of the telescope, Simon Marius recorded a dull pale blue light which increased in brightness toward the center like a candle shining through horn. And any one of you who've observed Andromeda understands fully that definition. Now, the first good guess as to the nature of this little fuzzy patch in the sky came from French astronomer Pierre-Louis Maupertuis. In 1745, he said he thought these oval nebula-like objects that were being observed with telescopes were collections of stars. And he was the first to use the term island universes to describe them. Now, you have to understand that there was a tremendous bias in astronomy that lasted all the way into the 1900s, suggesting that these little oval nebulae were actually solar systems forming within our one and only island universe, the Milky Way. That is a bias that said the Milky Way was the center, it was the only island universe. The universe was static, it had existed forever, would exist entirely infinitely into the future. And even Einstein added a cosmological constant to his theories in order to maintain a static universe that would not have been static had he not added it. He later called it his biggest blunder. Charles Messier came along in 1764 and included Andromeda as object number 31 in his list of nebulae and clusters. And he mistakenly attributed the discovery to Simon Marius. Of course, Marius was simply the first to record it, in not really the first, since Al-Sufi had done it before him. But really, Andromeda had been seen by ancients, undoubtedly long, long before Al-Sufi recorded it in his book of fixed stars. Messier sketched a beautiful sketch of Andromeda and its two main companions that we now refer to as M32 and M110. And notice that he assigned the discovery right in the middle here to Simon Marius. Immanuel Kant was a philosopher. And Immanuel Kant, a German philosopher, and he was considered to be the father of modern philosophy and modern ethics. But he was also a very bright guy. And Immanuel Kant had this to say about the spiral nebulae. Now, bear in mind, he's not an astronomer. Consider what he said here. It is far more natural to regard the spiral nebulae as systems of many stars whose distance presents them in such a narrow space that the light reaches us in a uniform pale glimmer. Their shape, the feebleness of their light, which demands a presupposed infinite distance, all of this is in perfect harmony with the view that these elliptical figures are just universes, and so to speak, Milky Ways. Not bad for a non-astronomer. That was in 1775. However, because of this tremendous bias that still existed, he was pretty much ignored. Those of you who are pursuing League observing programs, we have some big ones with Mr. Herschel's name on them, the Herschel 400, the Herschel 2, and Herschel Society Silver and Gold beyond that. I've been after the gold one for quite a while. It's 2,400 objects, basically, and most of them very faint galaxies. And he attributed the distance to Andromeda at about 2,000 times Sirius's distance, or 18,000 light years, which of course would have put it right in the middle of the Milky Way. He even drew a map of the Milky Way, which he believed to be, again, the only island universe in a giant void of some sort. William Parsons, a British astronomer, erected a giant telescope near the town of what's now Birr, Ireland. It was then Parsonstown, and it became known as the Leviathan of Parsonstown. It was a 72-inch telescope, a reflector, largest telescope in the world for 72 years, coincidentally, until the 100-inch went into operation at Mount Wilson. And he began diagramming the spiral structures of galaxies. There's no surviving image of his drawing of Andromeda, but this one exists for his rendition of M51. And so you could see he was determining that these spiral nebulae, as they were called, had a spiral structure, and a very detailed one at that. Now, the first evidence of the truth behind the nature of the spiral nebulae came in 1864 during our Civil War. And William Huggins, a British astronomer, took a spectrum of Andromeda and noticed that its spectrum was not like those of other emission nebulae, like, for example, the Orion Nebula. Rather, it was more akin to stellar spectra, the spectra of stars, which would suggest that these were not merely spinning orbs of gas in the process of forming solar systems within our only island universe. The second bit of evidence came along in 1885 when a supernova erupted in the Andromeda Nebula. It was, of course, not called a supernova. It was thought to be just another nova of something occurring in our Milky Way, and it was called Nova 1885. It rose to about magnitude 5.85 at the brightest in August of that year. As it turns out, we now know it was a supernova, and it's the only one ever seen in M31, which is a little surprising because from studies that we've done measuring the amount of aluminum-26 in the universe, we now know the rate at which supernovas occur in standard spiral galaxies like the Milky Way or Andromeda, and that's about 2 per century. So we're a little overdue for one in the Milky Way, in Andromeda. We probably have had some in the Milky Way that we haven't been able to see. Now, Isaac Roberts took the first photograph of Andromeda. This was taken a little after Christmas in 1888, not really adding anything to the debate, but clearly depicting again in photographic form the spiral structure. Now, meanwhile, Vesto Slipher, very, very prominent astronomer working at Lowell Observatory. And Vesto Slipher, by the way, is the one who hired Clyde Tobbaugh to come from Kansas and begin the what turned out to be successful search for Pluto. He made a discovery that would be important later, and that discovery was in the process of taking the radial velocities of 25 of the spiral nebulae. He determined that 22 were moving away from us. Their light was redshifted, and 3 of them had velocity toward us, including Andromeda, which he calculated to be moving toward us at about 300 kilometers per second. But meanwhile, there were 2 developments unfolding that were going to resolve the mystery as to the nature of these spiral nebulae. In 1912, and I understand you have a program coming up about this incredible astronomer who I think should have won the Nobel Prize for this work. In 1912, she discovered what's called the period luminosity relationship of Cepheid variables. And without getting into that in too much detail, I will simply say that what she discovered is that there were Cepheid variables with different periods, 2-day, 4-day, etc. And that depending on the period of the Cepheid variable, it had a certain absolute magnitude that was consistent with that period. In other words, every, let's say, 2-day Cepheid always had the same absolute magnitude, which means that if you moved it forward or backward to a distance of about 32 light years, which is 10 parsecs, it would have the same absolute magnitude. All of them with that same period would have that absolute magnitude at a given distance. Whereas perhaps a Cepheid with a longer period would have a different absolute magnitude. This made Cepheid variables the equivalent of a standard candle. It's like knowing that if it's a 2-day Cepheid, it is a 60-watt bulb, and if it's a 4-day Cepheid, it's a 100-watt bulb. And standard candles prove to be vital in determining distances to galaxies. Now, notice that we had, for many of the Cepheids that she studied, we had distances. So here, for example, these numbers are meaningless. They're just for demonstration purposes. Let's say she saw a Cepheid variable with a 2-day period that parallax said was at 10 parsecs, and it had a visual magnitude of +3, so it also had an absolute magnitude of +3. She observed another 2-day Cepheid, but this one parallax said was 320 light years away. Okay, that's 10 times further away or 100 times fainter. And sure enough, it had a visual magnitude of 8, and that's 100 times fainter than magnitude +3. So it had the same absolute magnitude. This was an immensely important discovery. And the second major thing that was unfolding that was going to resolve the debate was the installation of the 100-inch reflector at Mount Wilson. And with that, the mystery would be solved, but it would not be solved before a great debate was held on the nature of the spiral nebulae. This debate took place on April 26, 1920 at the Smithsonian Institute of Natural History. Harlow Shapley, the director of the Harvard College Observatory, and by the way, the first president of the Astronomical League, and Aber Curtis had a debate before a packed house. Shapley argued that the spiral nebulae were in the Milky Way, and he based this on 2 things. Number one, he said another astronomer by the name of von Manen had detected rotation over just a period of years in the spiral nebula M101, which is a face-on galaxy. Well, if that's true, then obviously it can't be very far away. If it were a galaxy at a great distance and we observed its rotation, the stars would be rotating much faster than the speed of light. Von Manen was simply incorrect. His observations were faulty, but they were not known to be at the time of this debate. And Shapley also argued that the nova seen in 1885 could not possibly outshine an entire galaxy. So he still thought it was a nova, not a supernova. And he would have been right, that if it had been a nova, it certainly wouldn't have been so bright as to be visible to the unaided eye from Earth. Mr. Curtis, Dr. Curtis argued, though, that he had observed some 11 novae in the Andromeda Nebula, far too many for such a small area for it to be occurring at random in the Milky Way. And he also looked at the dark lanes in the photographs of M31 and likened them to the dark lanes we observe in our own Milky Way in the summer when we look up. And then in 1922, just 2 years later, Ernst Oppik, an Estonian astronomer, was able to correlate the rotational velocity of M31 to its mass, and using that was able to calculate its distance at 1.5 million light years. Nobody thought he was right, but he was right, almost, at least as to the distance. But the one who really solved the problem was Edwin Hubble. He's an American astronomer, of course, and in 1924, he had been working at the Mount Wilson Observatory using the new 100-inch. And he obtained the first proof that indeed M31, not M32, is listed here erroneously, I apologize, lies at an extragalactic distance. And that discovery came with this photograph taken on November 23, 1924. Now that's coming up on 100 years ago, this coming November. He discovered a Cepheid variable and marked it with an exclamation point. And because of the work Henrietta Swan Leavitt had done, he was able to correlate its apparent magnitude with an absolute magnitude that placed it, by his estimation, at 750,000 light years, meaning it could not possibly be part of our Milky Way and lay very far away from it, an island universe unto itself. The debate was truly over at this point. Hubble, in December, right after his discovery, published his findings in the New York Times. The following January, in 1925, he published it in notes of an American Astronomical Society meeting, but it did not appear in a peer-reviewed journal article until 1929, still fighting to overcome the bias, such as the force of that Milky Way-centered static universe that had been dominating thought for so many years. Later, of course, Hubble was able to take Vesto Slipher's work demonstrating the radial recessions of these spiral nebulae corresponding to the Cepheid variable distances, and he was able to determine that the universe was expanding, a second major discovery that he made. So the debate was over. The Milky Way was one of countless island universes in an expanding universe, and what we've learned about the galaxy, the Andromeda galaxy, is that it's 152,000 light years across, has approximately 1 trillion stars versus our 200 to 400 billion in the Milky Way, and is the apparent king of the local group of galaxies, which consists of Andromeda, M33, and the Milky Way, M33 being the smallest of the three. Now, the question as to who's the king of the local group, not so clear, because just last month, on February 15th of this year, the International Society for the Radio Astronomy Research published notes in the Royal Astronomical Society proceedings indicating that their determination, which was based on a terrific amount of research, placed the mass of both the Milky Way and Andromeda at approximately 800 billion solar masses. And it's clear that Andromeda is larger physically than the Milky Way, but that the Milky Way may have more dark matter associated with it than Andromeda. So in terms of mass, we may be relatively equal. Andromeda is the 5th furthest permanent naked eye object that we can see. Here are the ones that exceed it. Once again, I have an error here. This first one should be NGC 5128. You probably are familiar with that as Centaurus A, and it has been seen naked eye under excellent skies and is the furthest thing ever detected with unaided eyes, 13 million light years. You'll notice in the footnote, there was a gamma ray burst that could have been seen visually if you'd been looking in the right place for the right 1 minute of time when it reached visual magnitude of about 5.5. Andromeda is not greatly dissimilar from the Milky Way. It's actually an older, somewhat redder galaxy than the Milky Way, but more luminous. And both of our galaxies, the Milky Way and Andromeda, lie in what's called the Green Valley, which is a medium luminosity galaxy that is sort of midway between hot and blue and older and redder, as you see here. The distance has been refined by virtue of studies done just about 15 years ago, a new Cepheid variable method, a new infrared surface brightness technique, and eclipsing binary research. All three concurred that the distance to Andromeda is about 2.54 million light years. That's about 15 quintillion miles. I have a thing that was given to me. It's this bowl of 1 million beads. This was given to me by an astrophysicist's mother, my good friend Richard Gott at Princeton. His mother heard me say one Christmas that I wish I had 1 million of something to show people. And the next Christmas I showed up and this garden club president had a garbage bag in the middle of her dinner table. This was not consistent with her sense of beauty, and unveiled it, and this was the gift. It's an incredible thing. Contains 1 million beads, as I said. You see a little container down there at the bottom that has 1,000 beads in it. And the reason I use this for Andromeda is because I asked people to estimate how many bowls of beads I would need to line up side by side in order to have enough beads to accommodate every mile between us and the Andromeda galaxy. And the answer is I would need a line of bowls side by side extending from this table right here that you see in the picture all the way to the planet Neptune. So in the sky, if we could see the full extent of Andromeda with wide pupils, we would see that it's much larger than a full moon in the sky. It extends over 3 degrees in length and 1 degree wide. It's the largest of the Messier objects in apparent size in the sky, and the 4th brightest of the Messier objects behind the Pleiades, M24 and M7. Looking into the core of the Andromeda galaxy, we see that it has what looks like a double core. You can sort of sense here a red core and a blue core, and that's not inaccurate. As you look into the center, here is one of the cores called P1, which consists of red stars, and P2, which consists of blue hot young stars, which cluster around, and here's a more detailed view of it, that cluster around a black hole with a mass of 4.3 million solar masses. That's 4.3 million solar masses. That's about 32 times more massive than Sagittarius A star, which is the black hole at the center of the Milky Way. And here is an image showing the bright blue stars that huddle around this black hole at the center. Now, the black hole itself did something rather amazing. In 2006, you look up here in this picture, you see there's nothing here. This is the location of the black hole. These are other X-ray sources nearby. And it brightened. You can see it here. It brightened a total of 100 times. It later reduced to a brightness 10 times greater than it had been before. And apparently this is because the accretion disk became more active by virtue of devouring one or more stars. Globular star clusters abound in Andromeda. The galaxy has 460 of them compared to 150 in the Milky Way. This is G1 or Mayal 2, and it's the brightest globular cluster in the entire local group of galaxies. And it's twice the size of the great Omega Centauri galaxy visible in the southern hemisphere, or the deep south in the northern hemisphere. Interestingly, this globular is so big, it has a black hole at its core, 20,000 solar mass black hole. lending astronomers to believe that this is a galactic core of a galaxy that passed through Andromeda and had most of its halo and maybe spiral arms stripped from it. The most massive globular cluster known is G78 in Andromeda, and it too has a black hole at its core, 100,000 rather solar masses. And it's, again, the most massive one that we know of. We've also discovered in Andromeda a whole new class of globular clusters that are larger than 100 light years and tend to be less dense than most of the globulars that we're used to finding in the Milky Way. Now, in 2009, something really interesting happened. Astronomers were observing some stars in the Andromeda galaxy, and at this rough location here, what they noticed was one star over time passed in front of another star. And when it did, there was a brightening and a dimming and then a sub-brightening. And this was attributed to what's called a microlensing event caused by a Jupiter-sized planet that was involved in this transit. And the planet's identity is PA99N2. It's about 6.3 times more massive than Jupiter. And if fully confirmed, will be the first exoplanet ever discovered outside the Milky Way. Really incredible discovery just 15 years ago. Andromeda is considerably warped, as you can sort of sense from this, and it's warped most likely because of its two biggest companions, which are seen on the right down here, M32 and M110, which huddle pretty close to the galaxy. It's possible M33, which is the third major component of our local group, may also be contributing to this. Speaking of those companions, this is M32. Those of you who have observed Andromeda have undoubtedly seen it many times. This is basically the result of a collision that occurred of a small galaxy with Andromeda about 2 billion years ago. And what Andromeda did is it spit out its core like a peach seed, and that's what you're seeing here. This too, though, has a black hole at its center that may be as large as 5 million solar masses. So black holes abound in the Andromeda system. This galaxy has about 3 billion stars. Here's a close-up of it. It's about 7,000 light years in diameter. And the other major companion, M110, is about 17,000 light years long and has 10 billion stars. It's a very hot core with stars that are already engaged in helium burning, and does not have, however, any black hole at its core. Here are a couple of the other companions of Andromeda. This is NGC 185. And here we have the center of NGC 147. Now, these next two are really hard to see. This is Andromeda 1. Now, it's really tough to spot, but it's just, if you look right around here, you see some faint blue stars. I hope you can see those. In a bright room, you might not be able to. But in the background, there's a somewhat larger density of blue stars in the background here. And this is the Pegasus dwarf spheroidal galaxy, also just a slight increase in density that you see in this area of the photograph. In all, Andromeda has 40 companions, including M32 and M110, and they're scattered over 6 constellations: Andromeda, Pegasus, Cassiopeia, Triangulum, Perseus, and Pisces. And 9 of them lie in a plane that intersects the core of M31, which leads astronomers to believe that they may have had a common origin at some point. Now, the most interesting thing, of course, about Andromeda is our expected date with Andromeda, 4.5 billion years from now. Andromeda is approaching us at 245,000 miles per hour. Based on those beads I showed you, it must be obvious that's still going to take quite a while. The Milky Way and Andromeda will approach, pass each other, and then spiral into each other like this, while M33 does a giant loop around the outside, and we'll have front row seats to a collision that will occur. And I'd like to show you the NASA video that will show you exactly how this collision will occur. That's the local group. Here's the rebound. And then it settles into an elliptical galaxy as M33 still keeps its distance. Notice stars are being flung off in many directions here. These stars will probably become irregular or dwarf galaxies no longer associated with this system. Okay. Well, all right, hold on. Okay, let's see what's going on here. There we go. Now, what I want to show you now is how this will unfold from the viewpoint of Earth. This would be the view now, looking at the Milky Way and Andromeda, the small oval there. Obviously, this is a time exposure. You can't actually see it looking quite this good. But in about 2 billion years, Andromeda will be quite the sight for amateur telescopes and professionals alike. And in 3.7 billion years, even more incredible. At about 3.85 billion years from now, the halos of these two galaxies will be intersecting with such force that the gases will compress and begin massive star formation. This is a characteristic of any collision of this sort. At 3.9 billion years, the sky will be filled with new stars forming. At 4 billion years, M31 will be tidally shredded and the Milky Way entirely warped in the sky. The two cores will separate and then rebound in 5 billion years. And here you see them coming back together, the two nuclei of this rebounding system. And at 7 billion years, settle into a very bright elliptical galaxy. As we look in that direction, the night sky won't be so pleasant for us. What it's going to look like from a distance is pretty much like M86 here in the Virgo cluster, an elliptical galaxy, more or less spherical or perhaps shaped somewhat like a rugby ball. And it has been dubbed Milkomeda by some people. There are others who don't really like the name, but nonetheless, that's the thought as to the nature of this future entity. The halos actually of the two galaxies are already intersecting. The Milky Way is down here where you see the HST, and the Andromeda galaxy's thickest part of the halo extends more than 1 million light years from the galaxy itself, and ours similarly. So these two halos, the thin part of these halos, are already intersecting. And it may be that this collision in 4 billion years is not going to be the first time that we've had a near approach. Many astronomers believe that about 10 billion years ago, the Milky Way passed close, or in this case, from the Milky Way's point of view, Andromeda passed close and stole some of our companions. So some of those companion galaxies you see out there may be the product of theft in the past. So this galaxy gave us an end to provincial bias. It said the Milky Way was the only island universe, that the universe was static, that it was everlasting in the past and future. It taught us that there are countless other island universes, possibly as many as 2 trillion within the observable part of our universe. It taught us that the universe is expanding, that the universe had a beginning, and that it's a dynamic place even with collisions. It's our neighbor in space. And here might be the view looking back with a 12-inch f5 with a 32-millimeter Nagler Type 5. The Milky Way would fill the field with its large and small Magellanic clouds and a couple of NGC objects in the background looking in the direction that we would call Centaurus. So maybe they're giving talks somewhere in the Andromeda Galaxy tonight, in the great galaxy in their sky, wondering what it'll be like when we collide 4 billion years from now. So that's it, and I will stop sharing. And again, I want to thank you for the invitation to be here tonight. I really think the world of your organization, and every time I've had the opportunity to speak with you the last 3 years, I believe, I've been just totally impressed with your observatory system, membership, and your success in fighting what I've been fighting here for a number of years, which is clouds all through the entire winter. And hopefully you'll have better luck. You'll have better luck with the eclipse in your travels, and I wish you safe travels to the eclipse zone.
Excellent. Thank you, Chuck.
You're more than welcome.
All right, perfect. Does anybody have any questions? If you're online, feel free to unmute. If you're here in the room, we have a question here. Yep.
Hello, just a quick question. You mentioned Mayall 2 and how it's bigger than Omega Centauri. Do you happen to know M54, which is presumably the core of a dwarf galaxy, I believe? It's also in that same class of size, right, as a globular?
And it is, yes. But I'm sorry, I didn't understand the question.
Can you hear me?
Yes.
I was just curious because I thought I had read somewhere that M54 might actually be in the same class as those, bigger than Omega Centauri, but not quite as big as Mayall 2. I was just curious if you had heard that.
I had not that it was larger. Omega's pretty big. I'd have to research that. I'm not sure about M54. I've observed it a number of times. Omega Centauri is just enormous. So I don't know the answer to that.
Okay. Right. Thank you.
Mhm.
Is there anyone else that has any questions?
A bit of a comment. It's Mark here. So when I was online here, I was poking around. I found on Wikipedia, I was kind of looking for a map of the local galactic cluster around here, and it showed a rather interesting map, 3D map of the area, showing Andromeda and the various dwarf galaxies in the region, up to about 8 million light years.
Yes.
Poking around, take a look at that. And to add a little fun here, I asked one of those old jokes about how long would it take to drive to somewhere like to Mars. And one here from Quora came on. This one guy says, walking to the Andromeda Galaxy would make essentially no difference whatsoever to travel and such. But one guy comes back and says, if you tell my ex-wife that there's a shoe store having a big sale in the Andromeda Galaxy, I expect she would take her less than 10 minutes to get there.
Well, you're probably aware that because of special relativity, if you could maintain a 1G burn for 1 year and drift for 28 years and then decelerate for 1 year down from very close to the speed of light, you could traverse the distance to Andromeda in 30 years of shipboard time. Of course, it'd be 2.5 million years in Earth time. It's an engineering nightmare because you need about 250 pounds of fuel for every pound of spacecraft. You cannot afford to hit so much as a sand grain approaching the speed of light. And when you got there, you'd probably end up 2 light years from anything interesting and have no way to traverse that. So and you can't come home again. So, I mean, special relativity makes it theoretically possible to traverse enormous distances, but it's just not a practical engineering feat that can be done.
But there's the other fun one is you aim that direct for where it is now, but when you try and get there, it ain't there where it is.
That's a problem.
Well, no shoe sales are going to be on Andromeda Galaxy anytime soon, so we're good for that. All right. Is there any more questions in-house or online? Okay, hold on.
Mr. Allen, thank you so much. I absolutely enjoyed it.
Thank
Can you-
you.
Yeah, so I am kind of new to the Minnesota Astronomical Society, but we've exchanged emails and I've invited you to present in April in Iowa. So
Oh, yes.
and you're going to be there in person. You're going to bring in your sample of elements. And I'm also inviting everybody here to either come down to Iowa or to Eastern Iowa, or maybe join on Zoom and attend that same presentation.
I'm looking forward to it. I just wish I could have come up there this time to be with you in person at this program. I intended to, and I told Ahmed that I wanted to do that, and it just became impossible. The eclipse was the real clincher. I could have probably rescheduled for.
Maybe I can drag him down to Iowa.
Okay.
He's my brother, by the way, so I can,
Yes.
I did
Yes.
that back in November and I can do it again.
Yeah, this element collection, you're going to find interesting. It's 100 elements. I know that seems impossible, but it's not. And it's an interesting program.
What was the date of the presentation from what, Noha?
The date of the presentation is April 27th. And I can share the website because the Zoom link is going to be on that.
Okay. And we can put it in the happenings too.
Yeah, we can do that.
So we'll share. We'll share. So, all right. Well, thank you very much, Mr. Allen. It has been a pleasure, and I hope to see you next time in person here. And just love having you, and it's always a fun and interesting. All
I love being with you, and thanks to all of you.
right. Thank you. Perfect. All right, well, that does conclude our presentation and meeting for this evening. We do meet at Pizza Luce afterwards for pizza, chicken tenders, whatever you want to do, and your beverage of choice. Otherwise, we will see you online on April 4th. No, don't come here to the meeting room until May. So, all right, everybody, have a good night.
Thanks.